Hello, I'll be presenting on the topic Migration of LINE's Android app from SPDY to HTTP2. My name is Oishi. First of all, let me give you the agenda of the session. First, I'll talk about the problems we had with the LINE app network stack. Then, I'll talk about how we revamped the network stack to solve those problems. And finally, I'll talk about what we were able to achieve with this revamp. First of all, let me introduce myself. My name is Masakuni Oishi, and I work in a department called LINE Communication Platform Engineering, which is responsible for the development of the communication platform, the foundation of the LINE client app. Recently, I've been working on a project to revamp the network stack of the LINE app. This is what I'll talk about in this session. There were some serious problems with the network stack on the LINE app. The first was that we were using the SPDY protocol as a base with our own push mechanism extensions. The SPDY protocol was originally introduced in the early days of the LINE app in order to make efficient API calls. However, now that protocols such as HTTP2 and HTTP3 have been standardized as successors to SPDY, the protocol used by the LINE app should be replaced by these. Another problem is that the coding of the network stack in the LINE Android app has become so complex that it is difficult to maintain. I mentioned earlier that the LINE app used its own push mechanism, which meant that we forked the open source library Netty and added our own customizations. This made the code much less maintainable. To solve these problems, we started a project to revamp the network stack of the LINE app. The goals of the project are threefold. The first is to migrate the protocol used by the LINE app from SPDY to HTTP2. And although this wasn't an immediate goal of this project, upgrading to HTTP3 in the future was also considered. The second goal is to stick to the standard specification and avoid customization where possible, as this tends to lead to technical debt later on. The final goal is to successfully complete the revamp of the network stack. In the unlikely event of a failure around the LINE app's communication, this would affect a very large number of users. This is why we have to be very careful during the migration process. In order to achieve these goals, there were a number of challenges. Firstly, all API calls in the LINE app had to be migrated from SPDY to HTTP2 at once. The second is that we have to provide bidirectional client-server communication over the HTTP2 protocol. Finally, the release of the migration has to be done incrementally to allow for rollbacks. We will now discuss these points in more detail. First, let's look at why we need to migrate all API calls at once. This diagram shows a flow in which some feature of the client makes some kind of API call to the server. The client's network stack is responsible for the communication of the API calls. In this diagram, The SPDY protocol network stack is doing the communication. The SPDY network stack establishes a SPDY connection with the server and makes the API calls over the connection. When one API call is finished, the SPDY connection is retained for a while and reused for another API call. In this way, multiple API calls can be handled over a single SPDY connection, making communication more efficient. Such a mechanism is called connection pooling. The same is true when an app makes an API call using the HTTP2 network stack. In this case, the HTTP2 network stack also has its own connection pool. Let's consider what happens when one API calls via SPDY and another via HTTP2 within the same application. The SPDY and HTTP2 network stacks each establish a connection to the server. So in this case, a single client application makes two connections to the server, one via SPDY and one via HTTP2. From the server's point of view, this doubles the number of connections received from the client. With the sheer number of active users online, this sudden doubling of the number of connections is unacceptable. As a solution to this problem, we have decided to create a common network layer in front of the SPDY and HTTP2 network stacks. Each feature in the app will use this common network layer instead of using the SPDY or HTTP2 network stack directly. The feature flag switches whether this common layer uses SPDY or HTTP2. This allows you to switch between SPDY and HTTP2 in the app in one go. The unused side of the network stack will not have any connections, so the number of connections on the server side will not double. Next, let's talk about client-server bidirectional communication. In the LINE app, there is bidirectional communication between the client and server to enable real-time chat. Some people may think of WebSocket when they hear the phrase bidirectional communication, but WebSocket cannot be used over SPDY connections. We have therefore implemented our own mechanism for two-way communication called SPDY Push, which uses a feature of the SPDY protocol called server-initiated streams. In SPDY Push, when a server pushes a message to a client, it sends data in the form of thin stream and data frames over the SPDY connection. This allows the client to respond immediately to the message from the server. However, the implementation of SPDY Push had a problem. That is, there is almost no existing network libraries that supports the mechanism used by SPDY Push. We therefore implemented SPDY Push by forking an open-source library called Netty and making our own customizations to it. However, this approach led to more complex code and made it more difficult to maintain. For example, when the original Netty library was later upgraded to support HTTP2, it was very difficult to reflect this in our customized code. Because of this, when we introduced HTTP2 into the Line app, we decided to implement a new push mechanism that we had to redesign from scratch. This is called streaming push. With streaming push, the client first makes a request to the server using the HTTP post method. The request body and the response body are each treated as stream of data that can be written at any time, rather than fixed length data. In other words, the request body of an HTTP post call is treated as an upstream, and the response body is treated as a downstream, and two-way communication is performed. This mechanism used in streaming push has been used in gRPC and is fully compliant with HTTP2 semantics. In the Line Android app, this streaming push is implemented using a network library called OKHTTP. In this way, we were able to implement bidirectional communication over HTTP2 in a standard compliant way without any complex customization. We have now implemented the mechanism for the Line app to communicate with the server using the HTTP2 protocol, but there was a bit more work to be done before we could roll it out. As mentioned earlier, we have made it possible to switch between SPDY and HTTP2 using a client-side feature flag. We have made it possible to change the value of this feature flag on a per-user basis based on server-side instructions. In this way, we can tell the server to use HTTP2 only for a subset of the users. In this way, we were able to test the system with HTTP2 enabled only for internal Line users. We started this test initially only with the developers working on the client app, and then later with all Line employees. This internal testing took over a month to complete, and we were able to identify issues. Once the internal testing was complete, it was time for public release. We started by enabling HTTP2 for 5% of our users so that we could roll back as soon as problems arose. We then gradually expanded the target group and rolled out HTTP2 to all users over the course of about a week. Fortunately, this public release went off without any problems. We were able to migrate the network protocol used by the Line Android app from SPDY to HTTP2. We introduced a new push mechanism for bidirectional communication over HTTP2 and were able to complete these rollouts without any problems. As a result of this revamp of the Line app's network stack, the Android client's networking code is now architected in a modern way using OKHTTP and Kotlin coroutines. Now that the QUIC and HTTP3 protocols are being standardized, which are further successors to HTTP2, how can we use them in the Line app? The main obstacle to moving the Line app from SPDY to HTTP2 was the SPDY push mechanism, which relies on the SPDY protocol. However, the streaming push mechanism we use now follows the semantics of HTTP, and these semantics will remain the same in HTTP3. Therefore, streaming push will work fine over HTTP3. In addition, the current implementation of the Line Android app uses a network library called OKHTTP as is. At the moment, OKHTTP does not yet support QUIC nor HTTP3. But in the future, when OKHTTP does, the Line Android app will be able to use HTTP3 with just a simple library upgrade. As you can see, it's very important from a long-term maintenance point of view that we try to follow standards as much as possible. Finally, I'd like to introduce you to our open source library called LICH. This is a collection of generic libraries for Android applications that we created for this HTTP2 migration project and other projects. Relevant to this topic is a library that provides extensions to OKHTTP and Apache Thrift to support Kotlin coroutines. Using this, you can, for example, make it easy to implement resumable downloads using range requests. The library can be accessed from this URL. We hope you find this useful. This concludes my presentation. Thank you very much for your kind attention.